This is AP Calculus Self-Check 8.1 Solutions. So we have this cable company and it's manufacturing cable. So we have $120 per meter that it sells for. So that's going to be our positive rate.
Seriously, no, is it supposed to be on the board?
It is supposed to be up on the board. I apologize. It's supposed to unfreeze it. And we have the 6 squared of x. That is going to be our negative rate. So this thing right here is our negative rate. And I know that this is a non-calculator question because it's number 3. Remember, on the free response questions, 1 and 2 are calculator, 3 through 6 are non-calculator.
Are they going to like tell us that, or are we just going to have to know?
They'll tell you that, but you should also know that going into it so you don't have to think about it.
Okay.
All right, so for part A, we need to find the profit for 25 meters of cable. So what there's a lot that I need to write in here, so I'm going to start all the way over here. So I need to do the integral between 0 and 25 of my positive rate minus my negative rate. So it's going to be 120 minus 6 square root of x, all of that dx. Okay, how do I find that by hand? So I need to separate this into 2 integrals. When I do that, I have the integral between 0 and 25 of 120 dx, and I need to subtract, and then here's a cool trick. I can do 6 times the integral from 0 to 25. I pulled out the 6, and I just am left with x to the 1/2 dx.
How did you what?
Wait a minute.
So it used to be 6 squared of x. I pulled out the 6. You can pull out constants. You're allowed to do that.
So you basically like distribute kind of.
Yeah, I distributed the integral. I separated it into 2 integrals.
And then you subtract. Okay.
All right. So
How'd you get x to the 1/2?
square root of x is x to the 1/2.
Oh, okay.
Yeah, good question. It's sometimes hard to see at first. So from here, I need to find this integral, and this is just a constant function. Remember, our trick for constant function is 25 minus 0, which is 25, multiplied by our number. If you need this rule, I'll write it down up here. If you have the integral from a to b of some number, this turns into b minus a times that number. So doing that, this integral here becomes 25 times 120. And I'm going to subtract this integral, which is 6 times, and I'm going to do the antiderivative now, so it's going to be x to the 3/2 divided by 3/2 is going to be times 2/3. I'll pause here to make sure that we can catch up.
I'm a little
You're lost?
behind.
Did you get to this step here, where you have 6 times the integral from 0 to 25 of x to the 1/2?
Yeah.
Okay, so 25 times 120 comes from this rule up here. It's the integral of a constant. Integral of the constant is just you subtract your bounds and then multiply it by the number. Subtract the bounds. 25 minus 0 is 25. That's where this 25 came from. 120 was the constant function.
Is that 6.2 over 3?
It is not. It's 6 times 2/3.
Oh.
I guess I could do this instead. All right, then x to the 1/2, I integrate, or I do the antiderivative, and it's going to be x to the 3/2. Divide by 3/2 is the same thing as multiplying by 2/3, and I still have my 6 there. And I need my bounds. That's going to be from 0 to 25. All right.
That's pretty complicated.
It is.
So basically, though, you're like finding the profit is like how much you made minus how much it costs to manufacture, but you just have to integrate it to get rid of the rates. That's why it's all like weird.
Exactly, yeah. The integration is
I
the,
just feel like I was thinking about it like
Simply.
Yeah, way too simply.
yeah.
It was like 6 times square root of 25.
Yeah, sorry, it's not that simple. Because
So that's your answer, or you have to simplify it down?
so I need to simplify this down, yeah. So I need to do 25 times 120. So I know that 25 times 12 is 300, and then 300 with an extra 0, so that's 3,000. So 25 times 120 is 3,000, and I need to subtract this integral. I noticed that when I plug in 0, this whole thing is going to be 0, so I really only need to worry about that 25. So, and this is another trick that we need to know from pre-calculus or algebra 2 whenever we learn this, which is 25 to the 3/2. How to simplify that. In fact, I'm actually doing that right now in my pre-calculus class. 25 to the 3/2 is the same thing as 5 squared to the 3/2. So 5 squared and The 2's cancel out.
Oh.
So you're just left with 5 to the power of 3. 5 to the power of 3 is 125. So that's 125 just with the x to the power of 3 halves.
I do not remember.
Wait, can you also write it as the square root of 25 to the third power?
You can.
Because that's how I remember it as. Like,
That's perfect.
You know, like the number on the bottom of the fraction is the square root, and then.
That works, yeah. And then the degree and the index will cancel each other out. Eventually, you should still get 125 from this. So this is going to be, and I'm going to simplify this too. 6 times 2/3. 6 divided by 3 is 2. 2 times 2 is 4. So this is going to be minus 4 times 125. Again, I explained where the 4 came from. That's 6 times 2/3. And the 125 came from up here when you simplify 25 to the power of 3 halves.
Where'd the 4 come? I'm just kidding.
All right, so this is going to turn into 3,000 minus 4 times 125. That's 500, because 2 times 125 is 250, times 2 again is 500. 3,000, yeah, you stole it from me. It's $2,500. Dollar runes. So,
Me too.
Me too.
I got $3,000.
wait,
I mean,
really?
yeah.
I got 2,800.
From this? 3,000 minus
Really?
500?
No, I got $3,000 in my original answer.
Oh, you're really close then.
He's like, really?
Yeah, he's like,
Really?
I thought you meant like,
Yeah.
you got this for the second
yeah,
step
he
with
was
me.
like, wow, okay.
So remember that when I'm selling something that is sold at a rate, remember that this is a rate. In order to just have a flat amount of money, I need to do the integral. That's how I knew at the very beginning to do an integral. Let's go to part B. Using correct units, explain the meaning. So, what does this thing mean? 25 to 30. The integral from 25 to 30 of 6 square root of x dx. That thing means
The amount of cost in dollars.
it's the total change
Just getting the total
change in position. No, not in position. In, what is our units here? In cost, in dollars. Change in cost.
We just hate the price.
Yeah, in the price. That works too. In price. And then you have to have your units. So here's my units in dollars. If you don't say in dollars, you don't get credit for this. In dollars. And then from 25 to 30, and what are our units here? Per meter. From 25 to 30 meters.
I don't know why I keep thinking total distance. Or, I mean, the amount.
In terms of the total change in this
Yeah,
thing?
Instead of, like, saying total change, I'm like, or total change, I'm like, the amount in cost in dollars.
Oh yeah, so you always need to remember the words total change.
What if I put means the cost of dollars per meter between 25 and 30 meters?
You still need to have these keywords total change. Yeah.
That's close.
So, because basically I wrote it as if it wouldn't have been the integral of it. Like, I just wrote it like that's the total cost of it per meter. But since it's the integral, then it changes to just what's the total change in cost.
In dollars, yeah, exactly. All right, going on to part C. Write an expression involving an integral that represents Mighty's profits and sale of cable that is k meters long. So this is using the fundamental theorem of calculus. So what was the initial amount? There is no initial amount. Okay, so our initial amount is 0. You don't have to put that. I'm going to put it in mine. Plus, and then we need our integral from 0 to, what is our variable here? X? Or is it k?
Okay.
Oh, sorry, it says k. 0 to k of the profit. So this is going to be, remember, it's just the same thing that we had from part A, 120 minus 6 square root of x. And then all of that needs to be in parentheses dx, or dk. No, it's in dx because this is the function in x, and then 0 to k because that's how many meters long it is. So that's our answer for part C.
I got that, but I didn't write the 0 plus.
Me either.
If you don't have the 0 plus, that's fine.
Oh.
Yeah, you still got that because you don't have an initial condition.
Oh.
I was just adding that extra to let you know that I am considering the initial condition, so you don't forget it in case there is one.
So if there is one, then it does.
Then you definitely need to have it in there. But since our initial condition was 0, just have this part.
And then if there wasn't an initial condition, you would put that below the k, like in that integral of 0 to k.
So it's always going to be 0 to k unless they say starting from 5 meters or something like that. Then you do from 5 to k. These zeros are not the same. This is the initial condition. This is the start of however many meters you're selling. All right, questions on C before I move on? On to part D. So we need to find the maximum. Okay, so we need to find all of the critical values. So it's not T, it's really K meters, I guess. So it's, I'm gonna put K here. I guess that makes the most sense. All right, so we have the initial point, 0. There's no end point, so we just need to find the next critical value. So how do we find that critical value?
Wait, is this in
Set
your
it equal
table?
to 0.
Set it equal to 0.
Is
Yeah.
this like a table kind of?
Is this a what?
Like, is this the table?
Table, yes. Because we're going to do start plus change. That's going to equal our end. But we don't know where that critical value is, and we don't have our calculator to help us out. So there is a critical value in here that we need to find. And
5
it is not
Let
25.
us use our calculators. It's the stupidest thing ever. What mathematician sits around and is like, yeah, I'm gonna do this just.
Pure
with my
mathematicians.
calculator."
Pure mathematicians do that all the time.
That's stupid.
In fact, not only do pure mathematicians do it all without a calculator, eventually they do high enough math where it's impossible to use a calculator. How do you do math in the 67th dimension? I'm not sure. You can't use a calculator for sure, though.
You're on
Yeah.
video saying that.
120 minus 6 square root of x, we need to set that equal to 0. So I'm going to add, or I'm going to subtract, or actually I'm going to add 6x, 6 square root of x. I was going to subtract 120, but let's just add 6 square root of x. So I have 120 is equal to 6 radical x. And divide both sides by 6, and I'm left with 20 is equal to square root of x. And to get rid of the square root, what am I going to do to both sides? Shout it out.
Square it.
Square it, yeah. So I'm going to get 400 is equal to x. And yeah, that's the only critical value. So I have to have 400. So you should have two values in here, 0 and 400. Our initial condition is 0 for both of these. We need to add the integral from, well, this is from 0 to 0. So you don't really have to have an integral there. I'm going to be lazy. And from 0 to 400, and then I'll actually write the integral out here of 120 minus 6 radical x. And all of that is dx.
So the steps we did on part A, that's what I did for this problem for some weird reason.
You do need to do them. But
No,
instead of,
I only did them. Like,
oh,
That's all I did.
yeah, so
Oh, wait, so because 400 is CV, is that the end?
it's not the end. The end goes towards infinity. I can sell infinity
That's why I got
amount of cable.
confused.
So
then how do we know what the maximum is?
since they didn't give us an end, these are the only two CVs that we can do. There's no other endpoint. There's an initial point. This is an endpoint, but there's no endpoint down here. So don't worry about it.
So then how do we know it's the maximum? Because like,
Because maximum has to occur at an endpoint or a CV. This is an endpoint. This is a CV. Since they didn't give us another endpoint, it can't occur there. All right, so now we need to actually calculate this thing. So I'm going to kind of skip a few steps because you've already seen part A. This is going to be from 0 to 400 of 120 dx. And I'm going to subtract, I want to pull out the 6 first, 6 integral from 0 to 400 of x to the 1/2 dx. Simplifying this a little bit, so this is going to be 400 minus 0, which is 400 times...
How do you get 0 to 40?
Sorry, I don't know why I did 40. It should be 400. Point, yep.
Thank you.
Make sure to remind me after the video. So now I'm going to do 400 minus 0, which is 400 times 120. So this is, I'm just going to write this as 400 times 120 so you know where all these numbers are coming from. And again, this is using our trick from our last slide up here, the integral of a constant. And I'm going to subtract 6 times, and this is going to be x to the 3/2 times 2/3. All of that evaluated between 400 and 0. Again, we don't have to worry about the 0. We do have to worry about the 400.
my head.
All right, so now when I plug in 400, this is a little bit of mental math. I'm running out of room here, and Carly's running out of lead. 400 to the power of 3/2. Maybe I can do that up here. I'll do this. 400 to the 3/2. Well, that's the square root of 400 to the power of 3. So square root of 400 is 20. 20 to the power of 3 is
800?
8 with 3 zeros.
You have 8,000.
Sorry, it is 8,000 because it's you have the 1 0 and then you need to square it again. And just to verify it, 20 to the power of 3, we did do that right. It is 8,000. So I have 8,000 times 4 because 2/3 of 6 is 4. So
2,400 or 24,000.
it's going to be 24,000. So I have this number minus 24,000. So 400 times 120. Get rid of the zeros and add them back in at the very end. 4 times 12 is 80. 48. I don't know what I'm doing. I got the 8 in there. It's 48 and then add the 0. So 4, 8, and then I'm counted 3 zeros. 1, 2, 3. I'm going to subtract. As Sophia said, this is going to be 4 times 8,000. So 4 times 8 is 32. Add the zeros back in. So 32. Add those zeros back in. And your final answer is 16,000 dollaroons.
That's all
hard,
of that
Mr.
without a calculator?
That is all without a calculator.
So hard.
And this wasn't even a part B, or yeah, this was just a normal 2009 AP calculus.
It was pretty
Question.
close, Mr. Sindel. I got 160. But it was just
That is really
wrong.
close.
It's really weird.
I had 1
All right.
over 400.
1 over 400. It's a little bit off.
I didn't know.
So I'm pretty sure like this might not be a good.
All right, on to 8.2. And so first thing, we need to divide everything up into intervals here. So the first thing, we definitely need to 3, and our final or in part C, we need to the entire interval. So we have to divide all these up. So this is how I divide my shapes up.
Same, Mr. Sindel, same.
All right, so this is going to be 2 times 200 divided by 2, so that's going to be 200. Each of these triangles is the same exact shape, 200, 200, and
For some reason I thought it was 100.
I'm just
It was like 1 by 200.
1 by 400. 400 to 800 is 400, and then divide by 2 is 200.
Okay.
So 6 to 8 is 2, 2 times 400, so this should be 400 here. And this is 1,200, this is 800, and this is 2,000.
Mr. Sindel, I got all the areas right.
Yes!
Me too.
All right, improvement. Hopefully you did, because this was also on the homework from last night. So yeah, we need these areas to solve for part A. How many people arrive on the ride between t equals 0 and t equals 3? So this is pretty straightforward because it's just arriving. We don't have to ask about what is the length of the line because we do need this 800. That's a negative rate. This is our initial condition.
I knew I should have included that in my C.
And our positive rate is judged by this graph here. So it's only asking for that positive rate. So we need the integral between 0 and 3, and it's of our positive rate, which is RT. So RT is our positive rate. That's our positive rate.
Oh, thank God.
Wait, so is 800 negative?
800 is the negative, yeah. So we don't care about the negative rate in part A. It's just asking how many people arrive.
Wait,
So-
what's the negative?
The negative rate will affect
I knew I needed to
part B and everything else from there. All right, so,
else?
well, B, C, and D will be affected by that negative rate.
So, but the negative rate is literally just 800 people per hour. It's not like a function or like.
Exactly. It's a constant function. So RT dt, and when we do that, so 0 to 3, that's going to be all of these numbers: 2,000 plus 800 plus 200 plus 200. Is that 3,200?
Yeah.
That's from the homework last night, so I was just going off of that. 3,200 people.
We're done.
And yeah, that's it. Okay, so that's part A.
Only one I'm gonna be good
Part
at.
B, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? So it'll all be the same. It'll be either increasing or decreasing. So what we need to find is the integral between 0 and 3 of our RT.
Isn't it 2 and 3, Mr. Sindel?
Sorry, I don't know why I'm writing 2 and 3. Or 0 and 3. That is a point. This eraser is the worst thing in this program. I have to like select everything to delete it. There we go. Between 2 and 3 of RT dt, and we need to subtract the integral between, I was going to do 0 again, 2 and 3 of 800 dt. All right, so when we do that, between 2 and 3, we need to come back to the graph. Between 2 and 3, it's 1,000. So this is going to be 1,000, oh, that's 100. 1,000 minus, and then 2 to 3. So I do 3 minus 2, which is 1, times 800. So this is going to be 800. That is 200. So we have a positive number. Remember, we're only looking for a number that is positive or negative. So to answer the question, the people waiting in line, the number of people waiting in line is increasing.
So, I'm sorry. Are you done?
We need to add something else, but do you have a question?
Well, I was gonna say, I literally did all that work and then I double
Checked?
Yeah, or I double guessed myself, and I was like, well, the slope is
Second
negative.
guessed?
Double guessed.
Second guessed.
Second guessed. And that's a.
Yeah, I'll tell you the truth. I told the slope is negative, but I should have known because they're not asking for the rate; they're just asking for the plain amount of people. So that's why you do the integral, right?
Right, yeah.
Yeah.
So you do the integral between 2/3 of RT minus 800. All of that dt is greater than 0.
I have another question.
Yes.
Do we need to add 700 to this? Because that's our initial condition.
You don't need to because that would be for the total number of people in line. This is just how much it's changing.
Oh, okay.
Is it increasing or decreasing? I mean, we could add 700 to both of these, but if you do that, you get 1,700 minus 1,500, and you'll still get 200
Okay.
on this interval.
So you got 1,000.
So increasing is the main thing to take away, and because we had a positive number. All right, on to new things. So this thing is going to be a mega question. I should probably move this up. Lots of work here. Here we go. At what time is the ride the longest? And how many people are at that time? And we need to justify the answers. Justify the answers comes from our table. All right, so we need to find initial conditions and CVs. So what CVs do we have?
None.
We don't have any CVs. Oh, this is maybe not as hard as I think. So
No, it is hard.
it is hard.
No.
Okay, so we need T, we need start plus change. That will equal our end. We have 7 more minutes left of class. We might be able to get through all of this. This is cool. Okay, so make that line a little bit longer. So we really only need our endpoints.
Me too, and I didn't even do anything else.
I know.
Ride the longest. So we need 0, and we need, oh, this is harder than I thought.
It's so hard.
Do you know why?
Because we have to do.
There's 2 functions.
Okay, just kidding.
Oh Lord.
There's 2 functions. What is one of the functions? Here's one of the functions, this line. What's our other function? 800. It's a flat line.
Oh.
So here's your flat line. In fact, I could grab that and change it to a different color to let you know this is a separate function. Where is the intersection of those functions?
At 3.
Right there. So that's a critical value that we need.
I always wondered why they like. Oh, just kidding.
Wait,
Why
so
do they
you
make 600?
basically to find your CV, you draw a straight line.
I need to have both functions. This function is 800. 800 is just a number. A number is a flat line. Flat line at 800. It's a constant function.
So hard.
All right, so we have our 3 CVs. We have 0, 3, and 8. 0, 3, well, 8 isn't a CV. It's an endpoint, but it's a point that we might have a maximum or a minimum. Our start value for each of these points is 700. 700 for all of these.
So we didn't need to like. Okay. Yeah. Just.
And then we need to add the integral. Well, this integral is going to be dumb. I'm not going to even worry about him because it's going to be from 0 to 0. This integral here is going to be from 0 to 3. And then what we need to do is, I'm just going to write RT minus 800. All of that.
Wait, I
D.
thought it was 800. Oh, just kidding.
And then this one's going to be 0 to 8 of RT minus 800. All of that dt. All right, so everyone understands where the 3 came from. That was the hardest part, I think.
Yeah.
And now we need to calculate these things, which is also kind of hard. Next hardest part, so 0 to 3 of RT minus integral from, I'm being informal here, I should be writing dt, but we're limited on time. 800, that's going to turn into, so 0 to 3 of RT, I think we already found that, didn't we? 0 to 3 of RT is 3,200 from part A. So this is 3,200. By the way, I should write a 700 here as a placeholder before I do the second part. 3,200 minus 3 times 800, which is 2,400. And that is 800, I believe, right? 800.
Plus 700.
Ah, plus 700. Ah,
Point?
yep, that's 0.2. So that's 1,500 because, yeah, that is 800. But then you need to add the initial condition, so this is 1,500. All right, then moving on, we have integral from 0 to 8. So we need to add up all of the area of RT, and then we'll subtract it from the integral from 0 to 8 of 800.
Mr. Snow, this is a dumb question I should have asked like 15 minutes ago, but like, how do you know 0 and 8, like, RT, like, how do you know the area of that?
How do you know the area between 0 and 8?
Or like, of
Like,
RT.
This is RT. See?
The whole thing is RT.
That whole thing is RT, yep. All right, so adding up all these areas, we had 3,200 so far with all of this. So I need to add another 1,200 plus 200, that's 1,400. So 1,800, so all of this is 1,800. Adding these together gives us 50,000, is that right?
Yeah.
Or
What?
5,000, sorry.
Okay.
5,000?
Yeah, I got 5,000.
All right, so
I
this is going to be
can't add.
5,000 minus
So dumb.
8 times 800, that's going to be 6,400.
Oh, for some weird reason I put 1,600.
It should be, yeah, 8 times 8 is 64. Add the 2 zeros. And this is going to be a negative. Well, does that make sense? A negative? Oh, wait.
But then plus 700.
Oh, yeah, that'll make sense. So plus 700. It's still going to be a negative, though, which is why I'm a little bit freaked out.
Yeah, that doesn't make sense.
That's going to be minus 1,400 plus 700, and you'll get a negative. So apparently you have negative people at the park.
The ghosts have come back.
I hope I did. I feel like I'm making a mistake because I'm getting a negative number.
Yeah, I don't think that doesn't sound right.
Unless
If I find an error, I'll upload a video for the error. But for right now, clearly the longest line is right there, and we need to know the time. So we need to actually have a conclusion here. So at t equals 3 hours, line is 1,500 people. So I'm going to say longest at that time. Perfect. And we have 2 more minutes to do part D, right? But do not solve an equation. All right, so this is just fundamental theorem of calculus. So we need the initial condition, 700, plus the integral from 0. Oh, hold on. We are doing this wrong. Be careful. The earliest time at which there is no longer a line for the ride. So when does this equal 0?
At 8?
Because remember at 8, we got negative 700. So sometime between 3 and 8, you should have a line of 0.
oh, 4 and 6. Between 4 and 6.
Between,
Definitely between 4 and 6.
so
I'm
I
not
don't,
sure.
so I think the way that we actually want to do this is we know that there's 1,500 people at time equals 3. So what we're going to do is we're going to say, well, you do 1,500 minus, and then it's going to be the integral between 3 and 8, not 3 and 8, sorry, 3 and whenever that time is, t, of our function, 800. Oh, sorry, this is also wrong because we need the positive rate and the negative rate in here. So the positive rate is
R of t.
r of t, thank you. And then we're going to subtract 800. And it's not r, is it r of t here?
Yeah, it is. Yeah, because that's the thing.
Okay, this is the mistake that we made. This thing is not t. What should this be?
Okay.
It should be r.
Wait, how did you get 1,500?
Wait, is it r?
Where did the 1,500 come from?
Because at 3
times
it's
2, which is
the end is
I think it can still be t.
and then for that
All this
all the way to
dt. There we go.
sometime between the 3 and 8,
Oh,
it turns to 0.
Okay.
What is that?
This class just really makes me depressed.
I think r is this. Perfect, so that is our answer. The reason that we had to start with 1,500, that was the last time at time equals 3 where we knew the exact distance of the line. Since we knew that distance, we used that distance, and then we subtract. This is now a positive rate because it's positive minus negative. So we take this rate and we go from 3 to t. Why do we start from 3 here?
Because that's that time.
The time at which we knew this was
And
1,500.
we're just doing that because that's the last time that we know the number of people.
Exactly.
But it could still work if we knew the number of people at 4 or something.
Exactly. If we knew the time at 4 and that was still positive, we'd start from 4.
Okay.
All right. Yep. And that is the end of class. Class ended 40 seconds ago. All right.